Four-stroke engine. Four-stroke engine. A four-stroke engine is an engine where to produce power require four steps up and down the piston, two crankshaft rotation and one camshaft rotation. The four processes are divided into cycles. Number 1. Suction steps. Aim to put air mist fuel into the cylinder. The resulting engine power depends on the amount of fuel burned during the combustion process. Process piston move from top dead point TDC to bottom dead point TMB. The inlet valve opens, pulls enters the cylinder. The cruises rotates 180 degrees. Open as that's 90 degrees. The negative pressure of the piston sucks the airfoil mist into the cylinder. Compression stroke. Starting when the inlet valve closes and the piston is pushed forward. The combustion chamber, due to the momentum of the crankshaft and flywheel. The purpose of the compression step is to increase the temperature so that the airflow mixture can complete. This compression ratio will also be closely related to the power production. Is process. The piston moves back from TMB to TDC. Valve in close, X valve remains closed. Fuel is compressed into the combustion chamber. About 15 degrees before TDC, the spark plug starts igniting and starting the combustion process. The crankshaft achieves one full rotation. Now can reach 180 degrees. Power step start when the airfoil mixture is ignited by the spark plug. Quickly the burning mixture propagates and there is an explosion which is blocked by the cylinder head walls, causing a high pressure backlash that pushes the piston into the cylinder bore. The linear motion of the piston is converted into the rotational motion by the crankshaft. The rotational energy is transmitted as momentum toward the flywheel, which not only generates power, the counterbalance weight on the crankshaft helps the piston make the next cycle. Process power step. The explosion was hit perfectly in the combustion chamber. Piston was struck from TDC toward TMB. The inlet valve closed completely, while toward the end of the machining step, the exhaust valve starts to open slightly. There is a transformation of the energy of the back and forth motion of the piston into the rotational energy of the crankshaft. Proof as rotation reaches 50 degrees. No can rotation is power is power steps. Step 3. The exhaust stroke becomes very important for smooth and efficient engine performance operation. The moving piston pushes the remaining combustion gas out the out cylinder to the exhaust pipe. This process must be carried out totally because a little residual gas from combustion is mixed with the introduction of new gas which will reduce the potential energy production. Is process number 1. Counterbalance twist on crankshaft provides normal force to move the piston TMB to TDC. X valve is perfectly open. Inlet valve is fully closed. The remaining gas from combustion is pushed out by the piston through the exhaust port to the exhaust. Number 5. For the crankshaft performance to full rotation. 5. Camshaft complete 1 full rotation. Difference of 4-stroke and 2-stroke. 2-stroke engine. A 2-stroke engine is an internal combustion engine where in one combustion cycle there are 2 piston strokes. In contrast to a 4-stroke rotation which has 4 piston strokes in one combustion cycle. Outdrop for process. Process is intake, compression, power, exhaust. Also for 2-stroke engine have also been used in diesel engines, particular opposite piston design. Low speed especially such as large ships engine and V8 engines for trucks and other heavy vehicles. There are 2 steps in the 2-stroke engine system. Number 1. Step 1. The piston move from TDC to TMB. Number 2. Second step. The piston moves from TMB to TDC. Difference of 4-stroke engine and 2-stroke. In a 2-stroke engine, in one crankshaft rotation occurs one combustion process, while in a 4-stroke engine, once the combustion process occurs in 2 crankshaft rotation. In a 4-stroke engine, it requires a valve mechanism to work with the function of opening and closing the intake and exhaust valves. While in 2-stroke engine, the piston and piston ring function to open and close the intake and exhaust valves. Initially, 2-stroke engines were not equipped with valves. In its development, a one-way valve was installed between the range camber, the carburetor with the end of number 1, so that the gas that has entered the range camber does not return the carburetor. will continue the video. The intake and exhaust holes one the two engines are not on the cylinder wall, while the four-stroke engine are not on the cylinder head. This is the main reason four-stroke engines do not use seat oil. Another difference is the two-stroke engine is more powerful than the four-stroke engine because the two-stroke engine completes one cycle faster than the four-stroke engine. Two-stroke engines are smaller and lighter than four-stroke engines. The efficiency of a two-stroke engine is lower than a four-stroke engine. The efficiency of the four-stroke engine is higher than a four-stroke engine. Two-stroke engine require oil mix with fuel, seat oil, two-stroke oil to lubricate the engine cylinders, while the four-stroke engine does not use additional oil. Two-stroke engine produce more air pollution. Pollution occurs from the combustion of seat oil and gas from the flushing chamber, which escapes directly into the exhaust hole, while the four-stroke engine produce less air pollution. Because the four-stroke engine does not use seat oil, the less air pollution is produced. Four-stroke engine lubrication is better than two-stroke engines. Two-stroke engine lubrication is not as good as a four-stroke engine, resulting is relative lower life of part in the combustion chamber components. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.